In this episode, we're going to tackle a topic that causes a lot of confusion for new learners: scoping boundaries in the cloud, and how to validate them precisely so security responsibilities are clear and controls are not accidentally missed. When organizations move parts of their payment environment into cloud services, it can feel like the cloud provider handles security for you. But that is only partly true. In reality, cloud security is shared, meaning the provider secures certain layers, while the customer secures other layers, and the exact split depends on the service you use. Scoping boundaries are the lines that define which systems, networks, processes, and data flows are considered part of the environment that must meet payment security requirements, and which are not. If those boundaries are wrong or vague, teams may protect the wrong things, fail to protect important things, or argue endlessly about who owns what. Precise validation is about proving the boundary is accurate by using clear evidence, clear data flow understanding, and clear responsibility mapping. By the end, you should understand why cloud scoping is tricky, what shared responsibility really means in practice, how to define and validate boundaries, and what common mistakes cause scope to silently expand. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. To start, let's define scope in a simple way that fits payment security. Scope is the set of people, processes, and technology components that touch cardholder data or can affect the security of systems that touch cardholder data. That includes systems that store, process, or transmit cardholder data, and it often includes supporting systems that can impact them, such as administrative management systems, identity systems, monitoring systems, and network controls. The point of scope is not to include everything, but to include everything that matters for protecting cardholder data. A key beginner misconception is thinking that scope is only the systems that directly store card numbers, but scope can also include systems that connect to those systems, administer them, or provide shared services. In cloud environments, this becomes more complex because services can be highly interconnected, and a misconfigured connection can create a new pathway into sensitive systems. Scope is also about documentation because you must be able to explain what is in scope and why, using a story that holds together logically. When scope is accurate, controls can be applied consistently, and audits and investigations become clearer and less painful. Now let's make shared responsibility feel real rather than abstract. Cloud providers typically secure the underlying physical infrastructure, like data centers, physical servers, and sometimes core networking, and they often provide security features and baseline protections for the platform. The customer is usually responsible for how they configure cloud services, who has access, how data is protected, and how applications are built and operated. The exact split changes depending on whether you are using infrastructure services, platform services, or software services, and beginners often get tripped up because they assume the provider's responsibility always covers the parts they find difficult. A useful way to think about it is that the provider secures the cloud, meaning the foundational environment, while the customer secures what they put in the cloud, meaning configuration, identity, and data usage. Even when the provider offers helpful defaults, you still must validate that you are using them correctly and that they match your risk needs. For payment environments, you cannot outsource accountability, even if you outsource technology, because you still own the responsibility to protect cardholder data. Precise scoping makes sure the shared model is translated into specific tasks, so nothing falls into a gap. Scoping boundaries in the cloud are often defined through data flows, because data movement tells you which components are involved. A data flow is the path information takes from one place to another, such as a customer entering payment information in a browser, the data being sent to an application, and then being forwarded to a payment processor. In cloud settings, data can pass through load balancers, application gateways, container platforms, serverless functions, message queues, databases, and logging services, sometimes without people noticing every hop. To validate scope, you must know where cardholder data might appear, even briefly, because that determines which systems require stronger controls. The challenge is that cloud services can make it easy to add components quickly, and those components can become part of the payment pathway without a formal design review. Beginners should learn to ask simple questions that reveal scope. Where is the data created? Where is it processed? Where is it stored? And where can it be accessed or observed? If you can answer those questions clearly, you can draw boundaries that match reality. If you cannot answer them, your scope is probably incomplete or based on assumptions. Another part of scoping boundaries is understanding trust zones, meaning areas where certain controls and protections are assumed to be present. In payment environments, the cardholder data environment is often treated as a high-trust zone with strong controls, while other parts of the business network are treated as lower trust. In the cloud, trust zones can be harder to picture because networks are virtual, services are managed, and connections can be created with a few clicks. Precise scope validation requires confirming that the trust boundaries exist as intended, such as confirming that only approved services can communicate with sensitive components, and that administrative access is constrained. It also requires confirming that supporting services like logging and identity are either in scope as part of the control system or protected in a way that prevents them from becoming weak links. Beginners should think of trust zones like rooms in a building with different security levels, where sensitive rooms require badge access, cameras, and restricted entry points. If a hallway connects a public lobby to a vault without a door, then the boundary is not real even if someone drew it on paper. In cloud, validation is how you confirm the doors exist and are locked. Responsibility mapping is the bridge between scope and action, and it is where shared responsibility becomes practical. Responsibility mapping means identifying for each in-scope component who is responsible for security controls, such as patching, configuration, access management, logging, monitoring, incident response, and backup. In cloud environments, some controls are handled by the provider for the service itself, but the customer still configures how the service is used, who can access it, and what data flows through it. For example, the provider might manage the underlying database engine and infrastructure, but the customer controls database access permissions, encryption settings, network exposure, and query auditing. Precise scope validation checks that every control has an owner, and that there is no ambiguity, like assuming the provider handles something when the provider does not. Beginners should understand that ambiguity is dangerous because it creates gaps that attackers exploit and that organizations only discover during incidents. Responsibility mapping also helps with evidence, because you can show how each requirement is met and who can prove it. When mapping is clear, teams can coordinate effectively rather than arguing during a crisis. A frequent scoping mistake in the cloud is assuming that managed services are automatically out of scope or automatically compliant. Managed services can still be in scope if they store, process, or transmit cardholder data, or if they can affect the security of systems that do. For example, a logging service that collects application logs might capture sensitive data if applications log it improperly, which can pull a service into scope unexpectedly. Another example is a storage bucket used for backups or exports, where someone might place a file containing cardholder data, even if the bucket was originally intended for non-sensitive content. There are also identity services, which might not store cardholder data directly, but if they control access to the environment, they can be critical to security and may need strong controls and monitoring. Beginners should recognize that scope is driven by reality, not by labels like managed or serverless. If a service influences confidentiality, integrity, or availability of the payment pathway, it matters. Precise boundary validation means checking for these hidden couplings and preventing scope from being based on wishful thinking. Another common issue is scope creep, where scope expands over time without anyone formally acknowledging it. In cloud environments, scope creep can happen when teams add new integrations, connect new services, or replicate data for analytics or troubleshooting. It can also happen when third parties gain access for support or monitoring, and then that access becomes permanent. Scope creep is dangerous because controls that were designed for a smaller environment may not cover new components, creating gaps in logging, patching, or access review. Precise validation includes periodic reviews that compare what is actually deployed and connected to what is documented and intended. This is where asset inventory and data classification become helpful, because they help you spot new assets and new data locations. Beginners should think of this like a house renovation where someone adds a new door without telling anyone, and the security system is never updated to cover it. Over time, the house becomes less secure even though nobody changed the original alarm settings. Cloud makes adding doors easy, so validation must be routine and disciplined. Clarity around third-party and cloud provider responsibilities is also essential because payment environments often rely on multiple vendors. You may have a cloud provider, a payment processor, a content delivery service, and various security or monitoring providers, and each one has its own role. Precise scoping validation includes documenting which vendor handles which part of the pathway and what assurances or evidence you rely on from them. That evidence might include provider documentation, service descriptions, contractual commitments, and reports that describe control coverage. Beginners do not need to memorize report types, but they should understand the principle that you cannot assume a vendor provides a control unless you have a clear statement or agreement that they do. It is also important to understand that using a vendor does not remove your duty to configure and monitor the parts you control, such as access keys, network exposure, and data handling. When vendor responsibilities are unclear, incidents become harder because each party may claim the other is responsible. Precise validation reduces that conflict by making responsibilities explicit before anything goes wrong. That preparation is one of the strongest defenses against confusion during a real incident. Finally, validating scope boundaries should include a mindset of evidence and repeatability because you want to be able to demonstrate the boundary, not just describe it. That means keeping documentation of data flows, system diagrams, inventories, and responsibility mappings, and updating them as the environment evolves. It also means having processes that require scoping review when changes occur, such as new services being adopted or new payment features being deployed. For beginners, the key idea is that precision comes from checking assumptions against reality and doing that regularly. If a boundary is based on a statement like card data never touches this system, you should be able to explain why that is true, such as because payment fields are handled by a processor-hosted component and only non-sensitive tokens reach your systems. If you cannot explain it clearly, you should treat the boundary as uncertain and investigate further. Precision also comes from limiting unnecessary connections and data copies, because the simpler the pathway, the easier it is to scope accurately. When scope is validated with evidence, security becomes a controlled program rather than a hopeful guess. As we wrap up, the main lesson is that validating scoping boundaries for cloud responsibilities requires clear definitions, clear data flow understanding, and clear mapping of who owns each control across the shared responsibility model. Scope is the set of systems and processes that touch cardholder data or can affect its protection, and in the cloud, that set can shift quickly as services and integrations change. Shared responsibility means the provider secures foundational layers while the customer configures, operates, and protects what they build and store, but the exact split depends on the services used. Precise validation checks trust zones and connections, confirms where sensitive data can appear, and prevents managed services and logging systems from becoming hidden scope expansions. Responsibility mapping eliminates dangerous ambiguity by ensuring every control has an owner and evidence can be produced when needed. Regular review prevents scope creep, and clear vendor responsibility documentation reduces conflict during incidents. For a new learner, the mindset shift is that cloud does not remove responsibility. It changes where responsibility lives, and scoping is how you prove you know exactly where that is. When boundaries are validated precisely, security controls become targeted, complete, and defensible instead of partial and accidental.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.